Hello, today we're going to be talking about equivalent expressions. We're going to look at identifying coefficients, variables, and exponents, and then we will look at combining like terms. Let's start off with identifying the coefficients, variables, and exponents. First of all, we'll take a look at the expression. And in the expression 3w, the coefficient is the number that is multiplied to the variable. So we'll write a 3. Our variable is the letter, the W, and it is W to the 1, so our exponent value is a 1. Next we have a squared. A squared is the same as 1 times a squared, so our coefficient is a 1. Our variable is an a, and the value of the exponent, it says a squared, so the value of the exponent is 2. Negative 4xy. Our coefficient is negative 4, and our variables x and y. And the value of the exponents for each is a 1. Negative g. Negative g has a coefficient of negative 1. The variable is a g, and the exponent value is a 1. So remember here for these is that we are looking for coefficients being multiplied to the variable and looking to see is it a positive or if it's negative. Okay, next we're going to identify like terms. You need to be really good at being able to identify what are like terms. So let's take a look at what classifies a like term. So terms that differ only by their numerical coefficients. So that means it has the same variable to the same exponent value. So here, 5b squared, so the b squared, cb, b, c, and b. When I compare all of these, the ones that are alike are the 6b and the negative 2b, because they both have b as their variable. Okay, b, x squared, xy, x squared, and y. So in here, the x squareds, I see that there's more than one expression with an x squared, so these are called like terms. Last example, PQ. This is called a constant. It doesn't have a variable, so if I'm going to combine it with something else, it needs to be another constant. Okay, this is Q squared. This is a constant, and this is PQ. So in here, I notice that I have a 3PQ and a 1PQ. Those are like terms. I also have constants. I have an 11 and a 3. So these would be grouped together. So again, just make sure that you're looking at the variable, making sure that it's the same letter to the same exponent, and that tells you that they're like terms. We're not worried about the coefficient that's in front, we're just worried about the variable portion to identify. We need to know that because next we're going to look at combining like terms, putting together what goes together. So identifying the like terms. In here, I notice there is a 4x and a minus 2x. No other x's. These two can be combined. And I just combine them with, I'm starting at positive 4x. I will take away 2x. That means I'm left with a positive 2x. Okay, next, positive 3 minus 6 or plus 3 minus 6. It's telling me that I start at positive 3. I will take away 6. I'm left with negative 3. Okay, so my simplified expression is 2x minus 3. Next example. 2x squared plus 3x minus 1 plus x squared minus 4x minus 2. In here, I notice that we have a 2x squared. Next, there's a plus x squared. I'm just going to put a 1 in front of there because that'll help me to combine like terms. Put those two together, starting at 2x squared, adding one more x squared, I'm at 3x squared. Okay, next, can look at combining our x's. So plus 3x minus 4x. Notice that I'm taking the sign that is leading the expression because that'll tell me where I start. So I'm starting with the positive 3x and I will subtract 4x from it. So starting at 3x, minusing 4, I'm left with minus 1x. Okay, constants. Minus 1, minus 2. So saying starting at negative 1, minus 2. That is minus 3. Notice that these are written in descending powers of x. So x squared, then an x, and then the constant last. It's a way of organizing so that if you get an expression like C where it's all mixed up, you know where to start. You start with the highest power of x. So here I'm going to look for the x squareds. These are like terms, they will go together. I'll write a 1 here in front, so I know I'm starting at negative 1, and I'm going to add 3. So negative 1x squared, add 3x squared, and I am at 2x squared. Okay, next, look for the x's. Plus 2x, minus 2x. Plus 2x and minus 2x are called opposites. When we have opposites and we combine them, we end up with 0. So I don't need to write anything down. Okay, last, this is a positive 4 minus 5. Positive 4 minus 5, left with negative 1. Okay, so my expression is 2x squared minus 1. Here are some other examples for you to try. Give you a head start on them, and I will start to put the answers on here to see how you're doing with them. So on the first one here, negative 4x squared plus 7x. B. B equals negative 5. The 2x and the minus 2x are opposites, and they will zero out. Okay, our last one, I'm going to look for the highest power of k. So I'm going to start with minus 2k squared plus 5k squared. That leaves me with 3k squared. Okay, here is 1k minus 3k. That combines to be negative 2k. So minus 2k I will write down. And last, the constants, plus 3 minus 4, negative 1. Here's my expression. Another example that I want to put on here is what happens if you have 2x squared plus 3x minus 4x as your expression. So when you're looking at this, there's just one term that has an x squared. It doesn't have anything that it gets combined with, so you just write 2x squared. It's just copying it out again. And then here, plus 3x minus 4x, these can be combined into minus 1x, so I will write minus x. Okay, over the last page of our notes just takes a look at a summary of the different things that we looked at. One piece I didn't mention was the notes on the side here, and it was just looking at, you don't